Hello everyone, let us solve this problem. Juliana plans to invest money for 10 years in an account paying 3.5% interest compounded annually. She expects the annual inflation rate to be 2% per year throughout the 10-year period. Juliana would like her investment to be worth a real value of $4,000 compared to current values at the end of the 10-year period. She is considering two options. Option 1, make a one-time investment at the start of the 10-year period. And option 2, you can read that silently, but let us solve first the question related to option 1. For option 1, determine the minimum amount Juliana would need to invest. Give your answer to the nearest dollar. You have to take note of this restriction that the answer must be to the nearest dollar. And you would like to find the amount Juliana would need to invest. So that means we're looking for the present value. Let's see how we're going to solve this. I'll show you some methods on the next slide. Okay, to put it simply, what we have is that we need to find the present value in such a way this will become 4,000 in the future with 3.5% interest, annual interest or nominal interest rate, but there is also a 2% inflation rate. So we need to find our real interest rate. So there are two ways by which we can solve the real interest rate. So we can have this formula, or simply we can have it nominal rate minus inflation rate. IB accepts this last formula. Okay, substituting the values, we will have our real interest rate here as 1.47058% and here 1.5%. Now we can use our finance solver or your graphic display calculator. So we will have this. We'll encode here 10. So the only difference is in the use of rate. If you use the formula, then we will have this. And if you use the other simpler one, okay, our answer differs by $10. So both of these answers for present values are acceptable. So if you answer this, it's correct. If you answer this one, it's also correct. It depends what you use in the interest rate. Okay, let's find other method in solving this. Another way of solving this problem is using a compounding interest formula. I have it here written here. This is from your formula booklet. So this is it. And then we just substitute the value where A is the future value from our problem. It's equal to 4,000. And our present value is missing here. Our N is the compounding period, which is just annually, so it means 1. And T is the time, which is in 10 years. Our R is already computed to be 15%, which is the real interest rate because there is an inflation rate. So solving for P, you can use numerical solve. It will give you an answer, which is 3,400. This one, 3,446.67. That's rounded off to the nearest dollar as is stated in the problem. All the answers must be to the nearest dollar. So this is the answer, 3,447. And this is similar to our answer in method 1. I think in method 2, you can just go over the next, over the previous slide. Okay, so let's try to find another way of solving this problem. Okay, in this method, we are going to calculate our future value, including the inflation rates. If you remember, we have in our previous methods, our future value, the desired future value is 4,000, but we already have our interest to be 1.5%. This is adjusted already. We have the nominal rates minus the inflation rate, and that gives us 1.5%. Interest rate. So for this, we're going to find the future value which includes the inflation rate. So it's going to be 4,000 times 1.02, which is a 2% inflation rate, to the 10th power, because that would be in 10 years. So in 10 years' time, your future value will be 4875.977. Now we can use our finance solver of your GDC. So we encode our future value, but these already have the inflation rate. So we retain here the nominal rate of 3.5%. Interest rate. So we're going to look for the present value. It's going to be, the answer is $3,457 to the nearest dollar. Or you can say also that our future value that includes inflation rate is equal to whatever is the present value compounding yearly or annually by 3.5% interest. So here you can use your numerical solve. You can choose any variable for PV. You can write here X or any other letter in your numerical solve, or N. Okay, it's your choice. Then we'll have a present value which is also the same, $3,457. So now you have seen a lot of ways by which we can solve question number 1 of this problem. We will proceed to question number 2. In option 2, Juliana invests $1,000 at the start of the 10-year period and then invests X dollars into the account at the end of each year, including the first and last years. So how is option 1 different from option 2? In option 1, Juliana is giving gave one-time payment or one-time investment, whereas here in option 2, there is a payment of 1,000 and a recurring payment of X dollars every year, or starting from the first up to the last year. So starting from year 1, so we say year 1 is 1,000, and then from year 2 up to year 10, there is here a recurring payment, including the first, so recurring payments of X dollars. So what we would like to find out is how much is this amount that is paid every end of the year. Okay, so let's take a look at the next slide. Here is the solution. First, we calculate the future value, then we find the PMT, or the recurring payments. IB reported that this item is poorly done because the students didn't recognize the appropriate future value, or FV, with inflation rate. From our previous method, when we use future value with inflation rate, we get this value for 875.977. You can pause this and go back to that method. But since this already include the inflation rate of 2%, we retain here the nominal rate. And you can see we still have the same result, 3457. Okay, so in case you didn't use this method, okay, if you didn't use this method, then you can still use the other method, the method you use in question 1, which is method A, in looking for FB. So how are we going to do that? So wait, let me just erase this. So you can find the FV by using the present value that we have gathered from the beginning, from A, which is either 3456.67 or 3446.66. So we got this future value. Either of these two can be used. And I will not explain anymore why there is a $10 difference. You can go back to our previous solution. So knowing our future value with inflation rate, we can now calculate for the PMT. So we encode our data here. for NI, and it could be this one instead of this, okay, or this one. Okay, I repeat. And then PY and CY are the same one, annual, and then one-time payment a year is compounding annually. Our PV, or present value, is negative 1,000. This is the initial payment of Juliana, or investment by Juliana, and then after that, in the same year, she keeps adding X dollars, and the X dollars is the PMT that we're looking for. So you leave PMT blank in your TVM or finance solver, and then go back to it again and enter. You will have this answer. 296 is also accepted. Okay, so that ends the explanation for the solutions to these problems. You can always go back and review the concepts about annuity and amortization. Goodbye, everyone. See you again next time.